Today we're going to go into a new topic. We are still dealing with exponents, which is why this unit is on in this chapter or this lesson. But basically we're going to talk about exponential functions. So right here, so we are moving on from linear, which we've done pretty much the entire year, to now we're doing exponential. Okay, so let's talk about the difference. What does linear mean? Straight line, right? And that's what we've done pretty much the entire year. When we graph something, it's been a straight line. Now we're moving on to what's called exponential. And this is where things grow. And you'll hear people say like, oh, it grew so exponentially. They're talking about rapid growth or rapid decay, okay? Exponential growth is written, so y'all know how like linear we write like y equals mx plus b, right? Well, this form is called y equals a times b raised to the x power. That is the exponential form that we use to write equations. The a is the starting amount. The a is the starting amount. The b is the growth factor. Now, we're also going to learn decay factor, but for today, since we're only doing growth today, see it says exponential growth, then that's going to be our growth factor. Basically, like how rapidly is it growing? To find the growth factor, it's usually given to you as a percent. So they'll say something like, it grew at a rate of 3%. To find this number, you take your percent and change it to a decimal and add it to 1. So right here, this b is found by taking your percent, changing it to a decimal, and adding it to 1. So it's 1 plus your percent, which you changed to a decimal. So if it grew at 3%, what's 3% as a decimal? 0.03, so it would be 1.03. Now, your calculator will write the equations for you. Do y'all remember how we use stat to write linear equations? We're going to do the same thing for exponential equations, but instead of choosing linear option, we're going to choose the exponential option. So right here, I want you to write your steps. You're just going to go to stat, edit. You're going to put your numbers in. Yes? Then you're going to go to stat, calc, but we're not going to choose option 4 for linear. We're going to choose option 0, which is exponential. Okay, now wait, before we go any further, I want y'all to see what an exponential function kind of looks like on a graph. So I'm going to graph one right here. If you want to do like a little free-handed sketch, you've got your y-axis, excuse me, and your x-axis just like always. And an exponential function will start super, super close to like the x-axis. Like it is hugging it. It almost looks like it's touching it. And then it will just rapidly jump up and curve up like that. That's what an exponential function will look like when it's graphed. Okay, this line right here, do y'all see how it looks like it's touching the x-axis? It's not. It's approaching it. It's called an asymptote. So this is a word you need to know. So do y'all see where I wrote asymptote? An asymptote is a line that it approaches but never touches. A line, the graph, approaches but never touches. Now in Algebra 1, the asymptote is almost always the x-axis, which is y equals 0. But once you get to like Algebra 2 and upper level maths, like it'll be a different type of asymptote. It can be anywhere. But our exponential functions, the asymptote is almost always y equals 0, which is the x-axis. So what's an asymptote? A line that it approaches but never touches. It'll look like it's touching it, but it never does touch it. Okay, So here we go. We're going to write a function rule for this table. So where am I going to go in my calculator to do this? Stat. So you're going to go to Stat, Edit. And then you're going to put in your x's in L1 just like you would for linear functions. So -2, -1, 0, 1, and 2. And then y'all know that to put the 2 9ths in, you can either use alpha y equals or just do 2 divided by 9. Again, to put the fraction in, you can just do a division problem. All right, everybody got it in? Now we're going to go to Stat Calc. I want you to arrow down. So we have always used linear because all we've done this year is linear. I want you to arrow down past the 9. Do you see the 0 right here where it says exponential? That's the option you're going to choose, option 0 for exponential. And then you're going to hit enter until it gives you the answer. Notice that it tells you that the equation form is y equals a times b, which b is raised to the x power. That is this function right here. Yes? Okay, so it told us that the a is 2 and the b is 3. So my equation is y equals 2 times 3, and the 3 has an exponent of x. So in exponential functions, the exponent is the variable. It's the one that changes. Easy? All right, try the second one on your own. We'll just do that one and then we'll move on. Y'all remember how to clear out your list, correct? Okay, so you just go up, hit clear. Okay, now that I have it in, I go to Stat Calc, option 0, and my equation is y equals 8 times 2 raised to the x power. Do y'all have any questions? Y'all feel okay about this? Okay, so let's skip this one and let's go down to these. Now, on the other hand, what if they give you the function and they want you to fill out the table? Instead of using stat, what button would I use? But you're correct, but I need more. Where would I put y equals? Yes, they're giving me the function. They're giving me the equation. So they're saying, if you have this function, fill out the table for it. So I simply go to y equals, clear everything out, and I type in that equation, 2 raised to the x power. And then to fill out my table, I simply go to second graph or second table, and I just fill in the numbers that go. So when x is -2, y is 0.25. When x is -1, y is 0.5. When x is 0, y is 1, and so forth. Now, we want to look at the graph, okay? So if I hit graph, it's going to show me the graph. But I'm super zoomed out right now. So I'm going to go to my window and I'm going to change it. Y'all remember how to change your windows, right? So I'm going to change my minimum to -10 and my maximum to +10. And I'm going to change my y minimum to -10 and my maximum to +10. And then I'm going to go look at the graph again of this exponential function. Do you see the asymptote? Do y'all see it looks like it's touching the x-axis, but it's actually never touching, yes? Are we okay? Now, why did I have you graph it? Because it wanted you to identify the domain and the range. We haven't done this in a while. What is domain? X's. Does it ever stop going to the left? No. Does it ever stop going to the right? No. So what is my domain going to be? It keeps going forever. All real numbers. My range, somebody tell me what is range? The y's, the lowest point to the highest point. Does it keep going down forever and ever? No, it stops at the x-axis, do y'all agree? Which is at y equals 0. And then it goes where from there? Above it. So what would my range be? Y is it above it or below it? So y is greater than, it never touches 0. It's approaching y equals 0, but it never touches. So y is greater than 0. That is your domain and your range. Question? Change your windows, your minimum to -10, your maximum to +10. So you got to change your x minimum, your x maximum, your y minimum, your y maximum. I mean, you can change it to whatever you want to. That's just the factory settings. All right, let's try this one. So where am I going to go again to put this in? To y equals. So you just got to go up to your exponent and then put your variable in there. Did you get it? Yes or no? All right, so you put it in, you go to your table, and you go when x is -2, y is 0.11111, which is, does anybody know that as a fraction? If you don't know, look, watch. 0.11111, math, fraction, enter, it's 1/9. So that's a 9th. When x is -1, y is 0.3 repeating. Who knows that as a fraction? 1/3. When x is 0, y is 1. When x is 1, y is 3. And when x is 2, y is 9. All right, let's identify the domain and range. So hit graph. Most exponential functions, just so y'all know, are going to have the same domain and range. Okay? So is it ever stopping going to the left and the right? No. What is the domain? Y'all got to pay attention. What is the domain? All real numbers. Why? Because it keeps going to the left and to the right forever and ever. All right, what is the range? Y is greater than 0. All right, any questions on those? Now, I want you to skip these two. We're not going to go do more. Y'all already know how to do them. We're going to go down and we're going to compare exponential functions. So do y'all see this one? And do you see this one? And do you see this one? So this is called the parent function. Well, it's not really a parent function, but this is the one we're starting with. And then what did they add to it over here? They took it and they multiplied by 3. And then they did that. Instead of multiplying by 3, they multiplied by. So we're going to look at what happens to a function when you take it and multiply it by a number. Okay? And then what happens to it when you multiply it by a negative number. So first, let's go deal with this one. So do y'all get how to read this table? So this right here is this function. And they want us to fill out a table for it when x is -2, when x is -1. Yes? Then they want us to take the function and change it to this. And then we fill out the table for that one. Do y'all see how it's written? I didn't want it to confuse y'all. Okay, and then they want us to take it and change it again to this and fill out the table for it. Okay, so let's start with the first one. So go to y equals, and then type in 2 to the x power. And go to the table, and when y is -2, x is 0.25. When x is -1, y is 0.5, 0, 1, 1, 2, and 2, 4. Now, before we move on, I want you to go graph this right here. So when x is -2, here's 0 right here. X is -2, y is 0.25, which is like right here. When x is -1, it's 0.5. When x is 0, it's 1. 1 is 2. 2 is 1, 2, 3, 4. So it's going to look something like this. And it's going to keep approaching because this is the asymptote right there. Okay, now we're going to go do this one. So go to your y equals button. Type in 3 times 2 raised to the x power. And fill out your table. Do y'all see how the table is? This is still the x value. So when x is -2, y is 0.75. When x is -1, y is 1.5. And then once you have it filled out, I want you to graph that one. Now we're going to compare them. Okay? When we took y equals 2 to the x power and we changed it to y equals 3 times 2 to the x power, what happened to it? Look at the graph. So mine went from the blue line to the green line. It basically looks like they took it and they stretched it vertically. Like, do y'all see, like if I took my fingers and I pulled it vertically up, it is called a vertical stretch. So when you take a function, an exponential function, and you multiply it by a number greater than 1, it is going to cause it to stretch vertically. So we call it a vertical stretch. Now, you will be able to memorize that and not have to graph it to see. You'll just say, hey, they took this, they multiplied by a number greater than 1, it's going to vertically stretch it. Okay? Now we're going to take that same function, and instead of multiplying it by +3, we're going to multiply it by -3. Are y'all with me? All right, so let's go put it in our calculator to see the table. What do y'all notice? They're exactly the same as when we multiply by positive 3, except they are now negative. Okay, so go graph it. Notice that it is not going in the same direction on the graph. It's now going which direction? Downward. Okay, let's go over what we already learned so far. When we took this function, y equals 2 to the x power, and we multiplied it by 3, a positive number greater than 1, it made it a vertical stretch. Now we took y equals 2 to the x power, and this time we multiplied it by a negative 3. Yes? What happened to it? So look at the original one that I graphed in blue. It didn't just flip it down, did it? It first stretched it and then flipped it down. So it is still a vertical stretch. So it still looks like they went like this to it and then they flipped it down. Because isn't this a mirror of my green line? Yes? So first it was a vertical stretch. And then they took it and they flipped it, which we call that a reflection across the x-axis. So a flip is called a reflection across the x-axis. Okay, we're going to do one more. So on this one, your first function, we already did this, right? So I'm going to fill it out for you just so you don't have to. It's 0.25, 0.5, 1, 2, and 4. And then go graph it super quick. Okay, y'all got that part graphed? Now, what are we taking it and multiplying it by? A number less than 1. So what do y'all think is going to happen? Instead of a vertical stretch, it's going to be something different, isn't it? Okay, so let's go do it. So I already put this in my calculator if y'all want to write it down. It's 0.125, 0.25, 0.5, 1, and 2. And then you can go graph it. Okay, so when we took y equals 2 to the x power and we multiplied it by a fraction, we multiplied it by a number less than 1, what happened to it? We didn't stretch it this way. We didn't vertically stretch it, did we? We kind of horizontally stretched it, which is referred to as a vertical shrink. Or also known as a vertical compression. So I'm going to say it again. If you take the function and you multiply it by a number less than 1, like between 0 and 1, it's going to make it a vertical shrink. So what do y'all think is going to happen when we put a negative in front of that? It's going to flip it across the x-axis, right? So this one right here, if y'all just want to write it down, is the same numbers here except with negative signs. So negative 1.25. And then go graph it. Okay, so what happened when we took our function and we multiplied by a negative? First it did what? It did a vertical shrink, and then it did what? Reflection across the x-axis. Okay, put your name on your paper. On 1 through 2, you're just going to use stat. Which option? Option 0 to write your equation. Okay? Number 3 through 11 wants you to graph the function. Now, I would just simply put it in my y equals button and graph it. Yes? And then it wants you to identify its domain and range. So how many questions do you have on this part? 3, the graph. And then right here you could just put D for domain, R for range. Your domains will probably all be the same, so don't freak out, okay? And your range will either be y is greater than 0 or y is less than 0. It just depends on if it's going above or if it's going below. Are y'all good with that? Okay, flip to the back. You're going to do 12 through 17. You're not going to do 18 through 20. Okay, on 12 through 17, it wants you to graph the function. Then it wants you to compare it with this function. Now, I personally graphed both of them so that I could see what it was. But I already taught you all the rules. If you take this and multiply by a number greater than 1, it's going to be a vertical stretch. Yes? If you multiply it by a negative number greater than 1, it's going to be a vertical stretch that reflects across the x-axis. If you take it and multiply by a number that's between 0 and 1, like a fraction, it's going to be a vertical shrink. You see what I'm saying? Yes or no? So you're going to graph it, and then you're going to write if it's a vertical stretch, vertical shrink, or reflection. Some of them will have 2, because if it has a negative, it's going to be a reflection and a shrink or something. Okay? All right, you may get started.